This table is a fantastic overview of the ARM processor portfolio. Think of it as a detailed comparison chart that helps us understand the capabilities of different ARM processors. Let's start by looking at the far left column, processor class. You can see it's divided into sections. At the top, we have the classic processors like ARM7, ARM9, and ARM11. These are the foundational designs that came before the more modern Cortex family. Below them, you see the letters M, R, and A, which we've talked about before. Can you recall what they stand for? M is for microcontroller, R is for real-time, and A is for application. This table groups all the specific processor models into these families. Now, let's look at the columns across the top. They list different features. The architecture column is very important. It tells us which version of the ARM architecture a processor is built on, like ARMv4, ARMv7, or ARMv8. Think of it like software versions. Each new version adds more features and improvements. You can see a clear progression from the older ARMv4 to the newer ARMv8 in the Cortex-A series. The next column, performance DMIPS/MHz, is a performance metric. DMIPS stands for dry stone MIPS. It's a standard benchmark that measures a processor's performance. Dividing it by the clock speed, megahertz, gives us an idea of how efficient the processor is. A higher number here generally means more work done per clock cycle. For instance, notice the Cortex-A57 has a performance rating of over 4.0, which is significantly higher than the older ARM7 at 0.95. As we move across, we see columns for different technologies. For example, thumb, 2 instructions. A checkmark here means the processor supports this instruction set, which is a mix of 16-bit and 32-bit instructions designed to give good performance while keeping the program code small. You'll notice the Cortex-M processors all use thumb, too, as they often go into devices with limited memory. Let's jump to some of the more advanced features. Look for Neon SIMD extensions. Neon is a technology that drastically speeds up multimedia and signal processing tasks. It's like having a special math coprocessor. That's why you see it's available on almost all the Cortex-A processors, which are used in smartphones and tablets that handle a lot of video and graphics. The Cortex-M series, being simpler microcontrollers, doesn't have this feature. Another critical pair of columns are Memory Management Unit, MMU, and Memory Protection Unit, MPU. An MMU is essential for running complex operating systems like Android or Linux because it manages virtual memory. As you'd expect, all the Cortex-A processors have an MMU. The Cortex-M processors, on the other hand, often have an MPU instead. An MPU is simpler. It doesn't manage virtual memory but protects certain memory regions from being accidentally overwritten, which is vital for reliability in embedded systems. Finally, look at the Target OS column. This tells you the intended use case. Real-time means the processor is for systems that must respond to events instantly, like an automotive braking system. You'll see this for the Cortex-R and Cortex-M series. Platform, or platform/SMP, indicates the processor is designed to run a rich platform operating system. SMP stands for Symmetric Multiprocessing, meaning it supports multiple cores, which you can see in processors with MP core in their names, like the Cortex-A9 MP core. So, this table isn't just a list of facts, it tells a story. It shows the evolution of ARM processors and how each family is tailored for a specific job by including or excluding certain features. If you need a high-performance core for a smartphone, you look at the Cortex-A series. If you need a low-cost, low-power core for a smart sensor, you look at the Cortex-M series. This portfolio view is incredibly useful for understanding the entire ARM ecosystem.